Okay class, in this video we will be learning how to calculate the gradients of curves. Now the question for the reference of this concept which we will be doing is from book 3 exercise 7b question number 8. Now this is the question which we will be doing just to learn the concept of calculating gradient of curves. He says using the scale of 2 centimeter to represent on the x-axis and 2 centimeter to represent 5 units on the y-axis, draw the graph of y equals to 12 plus 10x minus 3x squared for the values of x which are from minus 2 to 5. Now that's the part 1 which I am going to do right now. And we know when such type of questions come, what we do, we make a table for them. What do? We make a table for them, and the values of x are from minus 2 to minus 1, 0, 1, 2, 3, 4 and 5. And the equation is y equals to 12 plus 10x minus 3x square. And what I am going to do is I am going to just place one by one into the whole equation and I'll get the values. Okay, this is a sample. What I have done, I have placed all the values in the relevant calculator and I have solved my equation for every given set of rules. Now what I have coordinates of x and y. What I need to do is I need to plot these coordinates on graph. And while plotting, I need to consider the one factor which is of scale and range. And the third mark is for freehand drawing. Now, the scale for x-axis is, for x-axis it says it is 2 centimeter to 1 unit, and for y-axis is it is 2 centimeter to 5 units. And what he has not given is range of y-axis. He has given you the range of x-axis for x which should be greater than or equals to minus 2 and lesser than or equals to 5. He has given you this, and he has not given you the range of y. And the range of y will see from here. The maximum value is 20 and the minimum value is minus 20. The range of y will see from our graph that the maximum value is plus 20 and the minimum value is minus 20 from this specific given range of x-axis. So all in all, the range of y would be from minus 20 to till plus 20. Now I will be preparing graph of this. Now you see the origin isn't in the center of the graph paper. Why? Because I had to manage my range. There was less range on x-axis, so I have slightly shifted my y-axis towards the left side of the graph paper. And the range and the scale is that for x-axis, every after 2 centimeter I am writing 1, 2, 2. Once again leaving 2, it's 3. Every after 2 centimeter I am writing 1 unit, whereas on y-axis every after 2 centimeter I am writing 5 units, 5, 10, 15, 20. Now the next step is I need to plot these points which I have already calculated onto this graph paper. These are the points I have drawn for it: minus 2 and minus 20, minus 1 and minus. After the plotting or marking of the points, what I need to do is I need to join all these points with free hand. As I have stated in my previous videos that never ever join them with a straight line. You need to have a free hand, and whenever there is a curve or turning, you always make a slightest of bounce, a very minimum bounce, a very minor curve on the tops. You need to consider these things, and obviously do not use scale with them. Now the requirement of the question is you need to calculate the gradient of curve where the x equals to 4 and where the line cuts y-axis. These are the 2 points where you need to have the gradient. So let's first talk about where x equals to 4. You see 4 and over here, this is the point. The question isn't to give the corresponding coordinates. The question is to calculate the gradient. Now, you see, gradient of the straight line is very easy. It is very fine that it's straight line. The gradient on a straight line for any two given points, it is same. But for curve, it is constantly changing. The gradient over here would be different, and over here it would be different. Now, how to calculate the gradient of a curve on a specific point? The answer to this is that we draw a tangent. Now, what is a tangent? Tangent is a line which just touches the circle or any curvy object or any curvy figure. It does not intersect, it does not crosses, it doesn't overlaps, it just touches. Now what I am going to do is I am going to draw tangent on x equals to 4. Now obviously consider the factor that I am going to use the pen just for the better clarity, or let's take the pencil. Now what I need to do is I need to draw my gradient in a way, my curve in a way that it just touches the relevant point. Now you see my curve just touches this point, and it is not overlapping, it is not crossing anything. Now I'm going to take any 2 points on this curve. I'm going to take any 2 points, any 2 points on this line. So the points which I am going to take are, I'll prefer that they are one way or another concrete. For example, this is one of the coordinate because this is 5 and minus 10, and the other, once again, it is totally up to you. You can take anywhere, any point, and I'm going to take the other one is this is 17.5, and over here it is 3.1 and 17.5. Now you see these are the 2 points on the curve. You can take any 2 points on the curve. After taking these 2 points, what you need to do is you need to calculate their gradient. Now how to calculate gradient? The formula of gradient is y2 minus y1 over x2 minus x1. So what I am going to do is minus 10 minus 17.5 over 5 minus 3.1, and the answer to this is minus 27.5 over 1.9. and after this I am going to use my calculator. And calculator is minus 27.5, 27.5 divided by 1.9. So the answer to this is 14.4. This is my gradient. On the other hand, I need to find the gradient when the line cuts y-axis. Now once again, what I am going to do is I am going to draw a point. You see, this is the point where the line is cutting y-axis. Now what I am going to do is I am going to simply draw a tangent over here as well, so it simply touches the point. This is the point where I need to find the gradient. After this I am going to take once again 2 relevant points on this curve. Once again, they could be like any points which you want to have. So I am going for, let's say, this point. This is 5 on y-axis and 5, 6, 7, 0.7 on y-axis, and on the other hand I need to take one more point over here, and once again this could be, I'm going to take this point once again because this was like this 17.5. There's no compulsion. You can take on the same side, you can take on the different sides as well. 0.55. Now once again the formula of gradient, y2 minus y1 over x2 minus x1. Now 17.5 minus 5 over 0.55 minus 0.7. So this is like 12.5 over 0.55. Oh, 0.55 minus 0.7. Minus 0.7. So the answer is 1.25. 12.5 divided by 1.25. The answer is 10. The answer is 10. So the gradient of the curve where it cuts y-axis is 10. Now this was what you will get marks for. This is what you people will get marks for in exams. Sir, whether we are doing the right or not, there is one more way to check that. The other way to check that is with the help of calculator. Now you people must be having such calculators with you. Now I'm going to focus over here. This, yes, you must be having a d over d of x over symbol over here. So what I'm going to do is press shift, draw this d over dx. You will get something like this. You need to write the equation over here as it is of equation of this curve, which was 12 plus 10, and I'm going to write x with alpha and x, then minus 3, and then once again alpha and x square. And this is the point where you need to calculate the gradient. So the point where I need to calculate the gradient of, for example, it was this point, I need to give the coordinate of x-axis. So the coordinate of x-axis were 0. The coordinates of x-axis were 0, 0, and whatever the coordinates are on y, I have nothing to do with that. I am just going to place 0 over here. The answer is 10. In this way I get my gradient exactly. So if you get 9.8, 10.2, this is somewhat fine. There is no problem in it, but to just cross check. And what I'm going to do is I'm going to do the same for this as well. I'm going to place 4 where the value of x was 4. So I'm going to place it 4, and let's see what I have. I have minus 14, and I have sorry, I didn't place minus, and I have minus 14.4. It is somewhat near to it. I can even, like, increase or decrease the values and get very accurate 14, but I suggest to my students that never ever go for the very accurate thing, always go for the near about things. Okay class, that's all for today. Thank you, have a good day.